Hi, this is Justin Crooks, AI7SG, and last video I showed you a circuit for generating RF energy out of using polar modulation. Today I'd like to show you a little bit about the circuits that can generate the amplitude and phase required for polar modulation. This is a LT-SPICE simulation of the LTC7891. It's a GaN-FET buck controller, and basically the circuit itself is made to generate a fixed voltage, but with some minor tweaks you can actually get the bandwidth well north of 20 kilohertz, which is plenty good enough for generating the amplitude for your polar modulation. Here I have basically, when you put a two-tone signal in, you're going to get this kind of rectified sine wave shape out of it. So this is a really good waveform to test your amplitude modulation on. You can see, the shape follows very well at the higher voltages, which also happens to be where the RF energy is highest. And you notice a little bit of wobble here at the lowest voltages. It is very difficult to get rid of this, but the good news is, if you're sitting down, somewhere around 2 volts, you're already 20 dB down from the peak, so whatever discontinuities there are 20 dB less significant than if they happened up here. That's kind of the beauty of polar modulation. At the high end, you have almost perfect linearity, but at the low end, you still have, it's very difficult to get away with, or get around some sort of discontinuities down here. So yeah, that takes care of the amplitude waveform. As far as the phase goes, I've been using the Pico 2 microcontroller by Raspberry Pi, and they have this special HSTX circuit. Basically, you put a clock in, it's going to double the clock rate and then shift out data for you. I have a little 8-bit DAC, and the circuitry is actually pretty handy in that it lets you repeat the same value up to 16 times. So I'm clocking it out at essentially 4 times the LO frequency. And because of this circuitry, I can actually repeat that 16 times, so I don't have to refill this FIFO, but every 64th sample or so, which is quite handy. So between the voltage waveforms from the LTC7891 and the phase waveforms from the Raspberry Pi Pico 2 and the RP2350, that's pretty much all you need for, up to 400 watts of single sideband output. Like and subscribe, and I'll try to post some more videos soon.